In this example, we are asked to determine any symmetries and then say if the graph is even, odd, or neither. In the first example, we see something that looks like a circle. In talking about symmetry over the x-axis, then we need to cut the x-axis and make sure that for every point on this side, there is a like point equal distance on the other side. We can see that examining this graph, every point would exactly match up over the x-axis with another point. So we would answer here, yes. In talking about symmetry over the y-axis, we would want to cut our graph over the y-axis and then make sure that for every point on this side, there's another point equal distance across the y-axis on the other side. And we can see if we folded this graph, every point would match up exactly. So the answer here is yes. Now, because the answer is yes on y-axis symmetry, then we also know that we have an even. Symmetry over the origin. That means that if you look at the origin, then there must be, for each point equal distance here, there must also be another point equal distance here. And that must happen for every single point. And we see that that does, in fact, happen. Now, because our answer is yes for symmetry over the origin, we also say that the function is odd. Now, you may think it's weird that we have something that's both even and odd at the same time, but because the definition has to do with symmetries, then we can have something that's both even and odd at the same time. Let's drop down to the next example. This one, we're talking about symmetry over the x-axis first. So if we look at cutting the graph along the x-axis, then for every point on one side, if you go across the x-axis, there must be another point equal distance on the other side. On this one, you see that there's not. So the answer here is no. Symmetry over the y-axis. We would cut along the y-axis, and then we would examine a point and say for this point, there would have to be another point equal distance here. There is not, so the answer is no. Symmetry over the origin. We would say, look at the ordered pair 0, 0, and then look and see if for every point here, there is another point equal distance across the origin. And you can see that there would be. So the answer here would be yes. Because it is symmetric over the origin, you would say that this function is also odd. Symmetry over the x-axis for the last example. If we cut along the x-axis, then we can see that for every point here, there's another point equal distance on the other side. So the answer there would be yes. Symmetry over the y-axis. If we cut along the y-axis, then for every point here, there would need to be another point equal distance on the other side, and there is not. So the answer there is no. Symmetry over the origin. That would mean that for the order pair 0, 0, for every point on this side, there would have to be another point equal distance on this side, and we can see that there is not. So the answer there would also be no. Because this is neither symmetric over the y-axis nor the origin, then we would say that it's neither even nor odd.